Histograms are a type of bar graph used to visually represent the spread or frequency distribution of a set of variable data. This 7QC tool is typically used to assess process behavior and demonstrate if the data follow a normal distribution. Understanding the nature of the population data observed is vital for choosing the right tools to further analyze the process. By analyzing the process, an organization can ensure the customer's requirements are met. In a histogram, data are grouped into intervals. The data should consist of enough data points to analyze the distribution effectively and conclude on its process effect. To create a histogram, the population data are first analyzed, and the number of different intervals are identified. The width of each interval is also determined. Typically, the intervals are of equal width. The data are then counted, and the frequencies are populated for each interval. This information is then plotted as a bar graph. The histogram is now complete. Unlike a typical bar graph, the bars are close together on a histogram to represent that the data are continuous in nature. The constructed histogram can then be analyzed for the type of distribution the data represents. There are several different histogram shapes based on the frequency distribution observed. The most common shape is a bell shape that is a unimodal or one-mode distribution. This shape typically represents a normal distribution where the cluster of data has only one mode or peak observed. This mode is generally equal or close to the mean of the data, or the average of the data. The next shape is a bimodal distribution. This distribution has two modes or peaks, typically indicating the possibility of having two different data sets from different sources, such as different manufacturing lots. Thus, the data need to be separated in order to accurately analyze the information. Another shape is a multimodal distribution, where the data consist of several peaks, or multiple modes. Multiple peaks are often a sign that the data are incorrectly grouped, resulting in an inaccurate analysis of the data. In this situation, the data also need to be separated for further analysis. The last shape is a skewed distribution. For this shape, the distribution could have a tail to the left, known as negatively skewed, or right, known as positively skewed, indicating that most of the data lie on one side of the mean or the other. Sometimes, when the upper or lower specification is bound by a maximum or minimum value that cannot be exceeded, data points are clustered closer to one side, resulting in skewed distributions.